This is Cern, the nuclear research laboratory on the border of France and Switzerland. It features the most powerful particle accelerator on Earth, the Large Hadron Collider, or LHC. What does it do? Well, it accelerates and collides particles at 99.99% the speed of light. And maybe it could produce the very first lab-grown black hole. The LHC is a 27-kilometer ring of superconducting magnets. Inside, it accelerates particles to move at almost the speed of light. These particles are bound to collide, and when they do, they produce enough energy to create new particles. We're talking about very small amounts of energy here. The numbers are so tiny that scientists came up with a new unit of energy to measure particle energies at that scale. It's called the tera-electron volt. 14 tera-electron volts give you new particles. 1 followed by 19 zeros of tera-electron volts would give you a black hole. If one of the experiments at the LHC ended with scientists creating a black hole, that black hole would be microscopic, as in quantum level small. It would have a mass about 40 million times smaller than the E. coli bacterium. It wouldn't get out of the accelerator and rampage across the planet, chewing up everything in its way. Well, it could get out, but because of its laughably small gravitational pull, it wouldn't attract a single piece of matter. The black hole would lose its energy through what's known as Hawking radiation long before it could gain any substantial mass, as if it never existed in the first place. Even when folks at Cern build a next-generation lab, the future circular collider that will outpower the Large Hadron Collider will still be pretty safe. For a lab-produced black hole to potentially cause any damage, it would need to have a mass of at least 0.00002 grams. That's about 50 times smaller than the mass of an ant. It would take that black hole 9 octillion years to reach the size of 1 kilogram, and another decillion years to swallow up the Earth. The whole process would take longer than the age of the universe. I'd say no need to worry about it at all. The Earth doesn't get destroyed every time physicists do something cool, unfortunately.
July 4th, 2012, and scientists from Cern, the European Agency for Nuclear Research, step in front of hordes of journalists to unveil a scientific discovery that signals a new dawn in understanding our universe.
It is a milestone. I think we can all be proud.
Researchers created what's been called humanity's largest and most complex scientific experiment. A 27-kilometer, one-of-a-kind machine buried some 175 meters below ground to discover the Higgs boson, a pivotal building block of our universe.
So the Higgs boson is a fascinating particle because it's the simplest one. This has completely changed our vision of also the universe, because corroborating the fact that there's a Higgs boson means that we live in a vacuum that is very special. So it has changed a lot on the way we think about our universe in general.
The boson is part of what physicists call the Standard Model, a way of explaining what for 13.8 billion years has held particles together, maintaining our universe. There's just one problem. No scientists had ever detected it. That's where the Large Hadron Collider comes in.
So we're accelerating protons in opposite directions to very high energies in a 27-kilometer long tunnel, and then we bring them to collisions in different interaction points where we have then experiments essentially recording the data. Highest possible energy mankind has generated in particle physics collisions so far, and we hope to achieve conditions which must have existed very close to the beginning of our universe, namely after the Big Bang.
The team almost halved the energy used by the system for the following years, so when they discovered the Higgs, everyone was a little shocked.
So there's a period of disbelief. Of course, as an experimental physicist, and when you're through observing something new, you just try to make sure that you're not observing something fake. When we finally accepted that it was there and then started to study it, so it was an incredibly exciting period.
But the Higgs discovery also reveals how much we still don't understand.
Now we really want to go beyond that model, because we know that it does not explain everything we see in our universe. As a matter of fact, it only explains 4% of the matter which we have in our universe. So there's much missing. And with the next phase of the LHC, we are now hoping to make new discoveries which go beyond our present understanding. There is theories out there which suggest that these microscopic black holes could be produced in high energetic proton-proton collisions. And if we indeed find first signs of these microscopic black holes, then this could open the path to new extra dimensions in our universe.
But for the team that first discovered the Higgs, now it's not just what they think they might find, but what they've never seen coming.
I would say I have two dreams. One of course, is to see something completely unexpected. And of course, there's also maybe another aspect. There are fundamental theories that are incredibly elegant, incredibly beautiful, on how they explain a lot of the mysteries that we have in our fundamental laws of physics.